Spatial orientation. How do we do it? Here we see a female using instructions on how to reach her destination. And here's a male. Is he using instructions? No. He's relying on visual cues. But he found his way.
Surprisingly.
This difference is well understood in vertebrates, and usually evolves when one gender shows a greater range of travel than the other. Does this hold true with invertebrates? Today we're going to find out. While our assistants get ready, let's think about it. If the basic needs of organisms are the same, we should see some similarities in behavior. The cuttlefish, Sepia officinalis, is a model organism to test. Not only does it have one of the most complex nervous systems among invertebrates and a rich behavioral range, but with a lifespan less than 2 years and sexual maturity not achieved until 14 months or later, competition among males for females is fierce. That means, to find that elusive mate, the mature male will travel further than females, and we should see some difference in spatial learning between genders.
Finding cuttlefish. For this, we go all the way to the English Channel. The sample population was obtained intermittently between February 2006 and September 2007. Don't worry, they'll each get their own home back in the lab with plenty of fresh seawater. Once there, they had to be separated by gender and maturity. But wait, immature cuttlefish don't show any external sexual dimorphism. We'll just have to guess for now, and later...
To test for differences in range of locomotion, each cuttlefish was placed in a large PVC tub colored white to avoid providing distractions. A grid overlay was used to measure how far they moved over 15 minutes. In fact, the results of a Cuttlefish ANOVA showed mature males traveled further than any other group. Whether it's driven by mating behavior still remains only a theory. Pairwise comparisons confirm these results, even though immature males had to be excluded since only 6 were discovered following dissection. A Cuttlefish test assumes a non-normal population, taking into account this non-representative sample.
Using a T-maze with visual cues at the base of the stem, the cuttlefish were offered a dark sandy goal compartment to escape the light. The original researchers surrounded the maze with black curtains to block out any distractions. For the first day, each cuttlefish was allowed to move down the stem and turn either left or right. As soon as they chose, they were removed and the real training began. The box opposite the cuttlefish's first choice was left open as the goal compartment and the other closed. Training them in opposition to their first instinct should ensure that the training is valid and not a byproduct of a previously acquired behavior. 5 times a day, each cuttlefish was given 5 minutes to choose to turn toward the goal compartment. Failure to do so resulted in immediate commencement of the next trial. Success was awarded with 15 minutes of peace and quiet in a dark box before starting again. Once the cuttlefish showed an 80% level of selection for the designated goal compartment over 2 consecutive days, it was time to test.
After visual cues were switched, both compartments were left open, and the cuttlefish were free to choose. If the cuttlefish still chose to turn in its trained direction at least 4 out of 5 times, it was considered to be relying on motor response. If instead the cuttlefish turned contrary to its training, it was considered to be relying on the now reversed visual cues. All the mature males exhibited this behavior. Interestingly, using the Cuttlefish ANOVA on the length of time it took to train them all showed no differences. Fisher's exact binomial test, however, confirms the prediction that mature males use visual cues to orient themselves, while all the other groups relied on motor response.
Assuming the contrast in ranges is driven by mating behavior and the hormonal differences present, most research will be confounded by the mix of male testosterone and female estradiol. When testosterone increases, the range of the organism follows suit. Estradiol's complicating effects in cuttlefish are not present because females do not have a reproductive cycle, thus allowing clear results based solely on testosterone influence.
In future research, the vertical lobe of the cuttlefish needs further study, as it is shown in other reports that damage to this part of the brain can affect spatial learning. It would be interesting to determine if this part of the brain plays any role in the differences we've just illustrated between males and females.